Okay, we are going to build a quadratic function with some very specific roots. We're being given the roots and we want to build a function that has those roots. And we did this in an earlier section with 8.1.2. We didn't have imaginary roots, we just had real roots. But we found we could build that function from its zeros by creating a factor for each of those zeros, and then we would have a function in factored form, and if we multiplied it out, then we could have the function in standard form. So we're going to do that here. The only difference is that the two roots we've been given are imaginary. They're complex numbers. We have 1 plus I root 3 and 1 minus I root 3. So our very first step is to write down that x equals each of those roots. We're basically just working backwards from what we do when we solve quadratics. And our final step in quadratics is we have the two or more values that x are equal to. Well, what we know is we want these equations to be equal to 0, because once they're equal to 0, that will show us the factors. So we're going to go ahead and subtract x from each side, and we have 0 equals negative x plus 1 plus I root 3, and we have 0 equals negative x plus 1 minus I root 3. And these are our two factors. So our function is y equals, and we go ahead and just put those in, negative x plus 1 plus I root 3, there's one factor, and negative x plus 1 minus I root 3. Now this is our function in factored form, but we want to go ahead and multiply it out so it's in standard form, especially because when you multiply imaginary roots together, often what we're going to see is it will end up giving us an expression that's real, that doesn't have the imaginary values in it anymore. But you can see this is a trinomial times a trinomial. We want to make sure we stay organized and don't lose any of our values. And the very best way for us to do that is to go ahead and set up a 3 by 3 generic rectangle, because once we set that up and multiply into each of the squares, it's really going to help us stay organized, make sure that we are multiplying each of our values, and it will also really help us simplify. So I'm going to go ahead and just put each of those terms that we're multiplying along the outside. And this way I can go ahead and distribute in my multiplication without having to worry about which one I'm multiplying by which. Negative x times negative x gives us a positive x squared. And I'm just going to multiply right down this first column. It'll just help me keep track of what I'm multiplying. Negative x times 1 is negative x. Negative x times negative I root 3. Well, a negative times a negative is positive. And then we have x I root 3. Our next column is just plus 1 times everything on the right. So those are all going to stay the same. And that makes it fast to multiply into that column. And then the third column, we have negative x, I root 3, I root 3. And then negative, we have an I squared. We have I times I. And root 3 times root 3 is just going to give us a 3. So we're going to want to go ahead and collect some like terms so we can write this in simplified form, right? I can see I have both of those terms. I have a negative x and a negative x. I can see these two terms, right, can be combined. And then the other thing we can do is we can go ahead and combine these two terms. And in fact, the negative I root 3 and the positive I root 3, those just add up to 0. And xi root 3 and negative xi root 3, those also add up to 0. So already my expressions become much simpler. The other thing I want to take a look at is in this bottom right hand corner. I have an I squared and a 3. Well, we know that I squared is equal to negative 1. So since we have negative, or the opposite of I squared, we're going to have the opposite of negative 1 times 3. Well, the opposite of negative 1 is positive 1, and positive 1 times 3 is just going to be 3. So let's go ahead and collect those terms and write them off to the right. We have y equals we have an x squared from the top left. We have minus 2x. We have a 1 from the middle. And we have a 3 from the bottom right. And so then that very last thing we're going to want to do is to go ahead and simplify by combining the 1 and the 3. And you can see this went from something really complicated to, once we multiplied those two complex numbers out, we actually got a quadratic equation that doesn't involve any complex or imaginary numbers at all. So here's what we figured out, that the quadratic equation y equals x squared minus 2x plus 4 has two complex roots, and they are 1 plus I root 3 and 1 minus I root 3.